This section has quite a few subsections in it. We're going to look at solving linear trigonometric equations that only have sine or cosine in them. So those are kind of the most basic, simple ones. It's sort of a way of getting us to the point of understanding what it means to be the solution to a trigonometric equation. But then we're also going to look at equations that involve other trigonometric functions like tangent or cosecant. We'll also be looking at solving trigonometric equations that are quadratic in form, and there's a couple of different types of those, so look out for that. That'll be a separate video as well. Solving trigonometric equations that use identities, and then a couple of other subsections at the end as well. We will also be looking this time at how to solve trigonometric equations using a calculator. So you've spent a lot of time now working on learning how to do trigonometry. And in order to do that, I've asked you not to use a calculator to find the value of, say, the sine of pi over 4, right? Your calculator can do it, but I've asked you not to do that. I've asked you to give your answers and exact values up to this point because I want to know that you're learning trigonometry, not just how to push the buttons on a calculator. At this point, we need to acknowledge that not every angle you'll be given is one of these common angles, pi over 2, pi over 6, pi over 4, right? Sometimes they're 1.7 radians or 12.203 degrees. And when that happens, if we're going to be able to do anything with the information we're given, the size of the angle, we need to be able to use a calculator. So it's about time we started doing some of that kind of work as well. All right, so for our first subsection, we're going to be looking at solving linear trigonometric equations in sine and cosine. The easiest type of problem we can do that is a problem like this is something that looks like this. The sine of theta equals a half. And really this looks like it's a pretty simple, straightforward type of problem to do. My table, and I keep this in my head, looks something like this. I'll start with 0, pi over 6, pi over 4, pi over 3, pi over 2, and then I have the sine of theta, 1, 2, 3, sorry, 0, 1, 2, 3, and 4, take its square root, divide it by 2. Right, now I don't need to do that every time. I'm just reminding you from a video that I put up earlier about how what do I carry around in my head, and this is what I carry around in my head. So if I simplify these, this is 0, and the numerator of this fraction here is 1, and the numerator of this fraction here is 2. So I'm going to get 2 over 2, and that's 1. So I have a 1 here, I have a 0 here, and I have a 1 here. And then the cosine is the same list backwards. 0, 1/2, root 2 over 2, root 3 over 2, oops, 3 over 2, and 1. So to solve this equation, all I have to do is look for the angle theta whose sine is 1/2. Where is the sine 1/2? The answer is the angle pi over 6. So here theta equals pi over 6. Now, that's part of the problem, or that's part of the solution, but there's another part. I'm going to put a unit circle down here. So I'm going to need some axes. Okay, and I'm also going to put the graph of the sine of theta. And I'm going to cheat and do a single cycle and then go back and put the measurements. And this is pi, this is 2 pi, this is pi over 2, so pi over 4 is there, 3 pi over 4, 5 pi over 4, and so on. And this is 3 pi over 2. We can get the rest if we need them. Now, we are looking at the angle pi over 6, the place where the angle has a sine of a half. That happens to be the angle pi over 6. So let me draw that in. There's pi over 6. And in fact, let me put it in yellow because I want it to stand out. I'll put it in the unit circle version at pi over 6, and I'll also put it in here at pi over 6. Okay, so that means that my y value there is a half. This goes up to, my scale's a little off here. This goes up to 1. This really should have been a little bit taller. Okay, so what I have here is the sine of pi over 2 is 1. The sine of pi over 6 is a half. The sine of pi over 6 is, the coordinates of this point are the square root of 3 over 2, comma, 1/2, right? So I have an angle whose sine is whose sine is 1/2. The sine is 1/2. It's right there, and that angle is pi over 6. However, if I go around again, then I have a second angle whose sine is pi over 6. How many times did I have to go around? I had to go around 2 pi. I had to add 2 pi to the first angle to get another one. And if I add 2 pi again, I get another one. And if I add 2 pi again, I get another one. So the answer is really not just pi over 6, but pi over 6 plus or minus 2 pi times some number of cycles. 1 cycle or 2 cycles or 3 cycles. We're going to call that k, and we're going to make the note k is an integer. Okay, k is a member of the set of numbers we call integers. Integers are whole numbers, positive or negative, and they include 0. So k can be 0, in which case pi over 6 plus 0 is pi over 6, and that is one of our answers. All right? So that's one answer, but go all the way around and then you have a second answer. That's when k equals 1. If you go around a second time, k is equal to 2. If you go to pi over 6 and then you go back 1, k is equal to -1, right? So that includes all the negative cycles. K can be a negative number. All right, so that's that, but also looking at it on the graph, you can see that the height of this graph is 1/2, not just at one place, but at 2 places. And then if I keep going forever, I didn't do a very good job there. This graph of sine keeps going forever too, so it's going to keep hitting the graph in multiple places. So I'm going to need to go back and look at the circle as well, because it turns out there's another place, even between 0 and 2 pi, there's another place where the sine of the angle is a half. Remember that each one of these quadrants will have an angle in it that has a reference angle of pi over 6. Let me draw those in. There's one in quadrant 2, there's one in quadrant 3, and there's one in quadrant 4, right? These are all reference angles of pi over 6. And so these are all going to have a sine of 1/2, except that in quadrant 1, it's positive. In quadrant 2, for sine, it's positive. In quadrant 3, for sine, it's negative. And in quadrant 4, for sine, it's negative. So going back to starting at 0, going around, finding the places where the sine of the angle is 1/2. What is the angle? The answer is pi over 6. It's also whatever this angle is. And this angle is pi minus pi over 6. That's 6 pi over 6. Take away 1 pi over 6. So that's 5 pi over 6. So there's actually a second solution here. It's 5 pi over 6 plus or minus 2 pi k, because I can go around once or twice or 3 times, or I can go to that angle and then go backwards once, go backwards twice, and so on. So this equation here actually has 2 parts to its solution. Here's one part, and here's the other part. And then we also have to include the statement that k is an integer. There are actually an infinite number of solutions to this equation, right? And you go to this one first and go around and around, right? There's an infinite number of solutions. If you look at it on the graph, there are an infinite number of solutions there as well, because I can keep going forever in both directions. That's why we started with such a basic, simple equation, because it's not quite as straightforward as it seems. Finding the primary solution is very easy, usually it should be. Finding the second solution is hopefully not too difficult. You have to remember there's a second place where sine is positive and has the sine of pi over 6 will be a half. But then you also have to recognize that there are an infinite number of solutions, and you have to tack this on at the back end of both of those solutions, right? And include the statement of what k actually stands for. So this was a pretty simple one. Let's do a slightly more challenging problem. And by slightly more, I mean, it looks kind of messy, but once we get into it, we'll discover it's really not that different from the one we just did. Now, this time I have a cosine squared in here, but we're not going to panic about that. First thing we're going to do, because I want to solve for theta, the first thing I'm going to do is isolate the thing that has theta in it. So I'm going to divide both sides by 4. And then we'll notice that we have cosine squared theta equals 3/4. And I can't solve that yet, so I don't know how to solve quadratic ones yet, so I'm just going to take the square root of both sides. That's going to give me cosine of theta equals plus or minus the square root of 3/4. That simplifies to cosine theta equals plus or minus the square root of 3/2. And if I look at my table, I have the square root of 3/2. That's for sine, so I need to be careful. Here's the square root of 3/2 for cosine. So the answer is just plus or minus pi/6, except it's not. So let's make our unit circle again. Put some axes on it. And certainly one answer is positive pi/6, and another answer is negative pi/6. Those are easy, right? We got, let's call that positive pi/6, and this one will be negative. We'll make that one pink. Those are two of our solutions. Certainly the cosine of this angle is either positive or minus, positive or negative, √3/2. And the cosine of this angle here is either positive or negative, √3/2. But starting here, I can go around again and find another angle whose cosine is positive √3/2. So one solution is pi/6 plus 2 pi k, where k is an integer. Another solution is negative pi/6 plus 2 pi k. Here I'm going to say that since we've defined k here, we don't need to write this out again here. Once you define it once, as long as you use it the same way each time, you don't need to define it again. All right, so we've taken care of all the solutions of this equation that give us an angle whose cosine is √3/2, all those rotations, all of those rotations, plus this angle and all of its rotations and all of its negative rotations. Those are covered by these two solutions here. I'm going to put a theta equals in here as well. Now we have to check and see where else is there an angle whose cosine is either positive or negative √3/2. We have all students take calculus, so all trig functions are positive in quadrant 1. We're looking for cosine. So all students take calculus, C for calculus. Cosine is positive in this quadrant. It's also positive in this quadrant because everything's positive there. And we've already got those two quadrants covered. However, in this case, we want positive or negative square root of 3/2. So we want these two angles as well. I'll use blue for this one and green for this one. What are those angles? Those angles are pi minus pi/6. That's 6 pi/6 minus 1 pi/6, which is 5 pi/6. And pi plus pi/6, which is 7 pi/6. So I need to add to my list here. 5 pi/6 and 7 pi/6 plus 2 pi k plus 2 pi k. Now there's another way to write this, and I'm going to come to that in just a minute. I do want to make the point that for each one of these solutions, you have to write plus 2 pi k. You just don't have to write this every time. You do have to write it once, but you don't have to write it every single time. It's interesting to note that another way to write negative pi/6 is as not negative pi/6, but the angle coterminal to that, or an angle coterminal to that, which is 6 pi/6. That would be 12 pi/6. That's 2 pi 12 pi over 6 minus 1 pi over 6 is 11 pi over 6 plus 2 pi k. So it's kind of your choice. I probably would use 11 just because it's positive, but it doesn't matter. These two angles are equivalent. And what we're trying to do is capture all the solutions. And I can either say all the way around to here and then keep going, or I can say go back a little bit and then keep going, right? It's kind of up to you. Now here's another observation. This is going to come in really handy. With a problem like this, because we basically want to capture all the possible solutions, positive or negative, right? We're going to run into this situation in other under other conditions as well. But for right now, let's just make this observation. This angle right here, or this terminal ray, if you will, the one that produces this pi over 6 angle, it's in a straight line with this other one down here. And I can say that with confidence because if I start at 0 and rotate pi over 6 and start at pi and rotate pi over 6, that rotation is, if this was a straight line, or if you took this as a rod and rotated the rod pi over 6, you'd end up here and here. The ends of the rods would end up there. So these are both pi over 6. So taking the x-axis and rotating it pi over 6 radians is going to give you this line right here. So that's a straight line. So now I have a kind of a different way to think about writing this solution. The two solutions that I have here are pi over 6, which was this one right here, and the one that was a little bit bigger than pi, 7 pi over 6. So instead of writing this as pi over 6 plus 2 pi k and 7 pi over 6 plus 2 pi k, I can write this as theta equals pi over 6 plus 1 pi k. Because to get all the solutions, I can go to the first one and then just go around pi and add pi and add pi and add pi, and I can do that forever. So this is a more compact way to get those solutions. Now to get the other ones, to capture the other ones, I can make the same observation. This angle right here is a rotation back from pi radians, right? If this is a rod and you rotate it back pi over 6 radians, you're going to get the rod in this position here, okay? Back pi over 6. So another way to write that is theta equals, let's go to the first positive one, and that is 5 pi over 6 plus pi k. And of course, if I'm writing my answers this way down here, instead of this way up here, then I have to include at least once k is an integer. Now in our previous problem, we didn't have this situation, right? We didn't have plus or minus. That was introduced because we had to take the square root, so we ended up with both positive and negative the square root of 3 over 2. So that captures the answers working with cosine. The positive answers were in the first and fourth quadrant. The negative answers are in the second and third quadrant. So we ended up in all 4 quadrants. But that's not always going to be the case. You're going to have to be careful about where your solutions are, whether they're positive or negative, whether there are 2 or 4 primary solutions, and whether you need to add pi over 2 or just pi to get to the next one. I would say certainly at this point, if you want to list all 4, that's fine, as long as you say plus 2 pi k at the end of each of them. But this is just a nice compact way to write that same answer. So those are the fundamentals, right? Ultimately, all of our trigonometric equations will have forms that we can boil down to, if you will, something that looks like this or something that looks like our previous example. But they're going to start out more complex. From this video, what I hope you took was what your answers should look like, where they come from, and how to present them. So with that said, the basics are out of the way. We're now going to look at solving equations involving a single trigonometric function. That's our next video.